Hi, welcome to the third video in the polynomials topic at higher. This video we're going to look at factorising polynomials. What we want to do by the end of this video is be able to use synthetic division to confirm or find factors of a polynomial and then hence fully factorise polynomials as well. Now, at the end of the last video, we looked at how if you are using synthetic division and you got a remainder of 0 at the end, then for your division there is no remainders, which actually means that your divisor and your quotient both have to be factors of your original polynomials. Now that becomes very useful if we are looking to factorise polynomials. Now, can you get this into your notes? This is your factor theorem. If you run through your synthetic division and get 0, then what you're divided by has to be a factor of f of x. And then the other way around, if it is a factor, then you have to be getting 0 when you go through your polynomial. Now, your example showing that x plus 5 is a factor of this polynomial. What we want is we want a situation where we're getting 0 at the end of our synthetic division. So we're going to set up our synthetic division. X plus 5 means that on the side of my polynomial, on the side of my synthetic division is going to be negative 5. For my polynomial, I've got 2x cubes, I've got 7x squared, I've got minus 9x, and I've got 30 at the end. And now I want to run through. So 2 minus 10, 3 minus 15. I'm sorry, that's minus 3, which will be positive 15, which will give you 6, minus 30, which will give you 0. Okay, now we have 0, which means there's no remainder, which means that x plus 5 has to be a factor. Okay, therefore, x plus 5 is a factor as f of negative 5 is equal to 0. And I'd always have that wee sentence in at the end just to confirm it. Well, it's not very neat, but f of negative 5 is equal to 0. So we've shown that something is a factor of a polynomial. Now let's start using that to fully factorise. Okay, so for this one here, we've got to show that it's a factor, but then we've got this extra step at the end. Now, what we're going to do is we're going to use our synthetic division. X minus 1 will turn into just a 1. We've got 1x cubed, we've got negative 2x squared, we've got 9 is 11x's, and we've got a 12 at the end. 1 comes down, times by 1 is 1, minus 1, which will be minus 1, which will be minus 12, which will be minus 12, which adds together to get 0. Therefore, x minus 1 is a factor as f of 1 is equal to 0. Okay, now get that in, make sure you're getting all your marks. Now that's us answered up until that point of the question. What we have to do now is factorise f of x fully. Now, from the previous video, we should be capable, or we should be comfortable of splitting this polynomial up into its divisor, which in this case is x minus 1, and its quotient, which we know comes from the bottom line. So that quotient becomes x squared minus x minus 12, and then you're looking to factorise that fully. So x minus 1 is not going to change, but in there you have two factors hidden in a trinomial. So it's going to be x and x minus 4 plus 3, and that is your polynomial factorised fully. So you can see now hopefully how with that synthetic division we've been looking at, you can get a remainder of 0, which tells you a divisor, which tells you when factors exist, which leads you down to being able to do many things with your polynomials. Okay, and lastly, this example. The difference with this example is actually we're not given any clues. We're not told what the divisor is. We're just asked to factorise it. Now, what we might have to do here is do a couple of synthetic divisions until we get to a point where we get a factor. Now, the one bit of information, the one clue we have here is this negative 15. Now, if you've got a whole number factor, which to be honest it always is at higher, you know it's going to multiply to give 15. So what I would do is I would work my way up to negative 15, use 1 minus 1, 3 minus 3, 5 minus 5, until you hit a 0. So let's go, and this might be a couple of times here, so bear with me. Let's use 1 on the right. We have 2, 5, minus 28, and minus 15. So 2 comes down, 2, 7, 7. That's minus 21, minus 21, right, that's not going to work, so that's useless. Okay, that's not working. Let's do it with minus 1 now. Okay, 2, 5, minus 28, minus 15 again. 2, that turns into minus 2, that turns into 3, which turns into minus 3, turns into minus 31, which turns into 31, okay, which is not going to give me 0. Okay, now the more you do it, the quicker you'll get. A lot of the time it does start off. If you start off with the lower numbers, you'll get it sooner rather than later. So that's 2, 6, 11, 33, 5, 15, and bingo, we've got a 0. Okay, that means that x minus 3 is a factor. Remember to turn your 3 around. Okay, since f of 3 is equal to 0. And what we can do now is we can factorise that one fully. Okay, we're dealing with 2x cubed plus 5x squared minus 28x minus 15. Okay, we know the divisor is x minus 3, and your quotient, which comes from here, is 2x squared, because we started with a cube, so now we're at a squared, plus 11x plus 5. And then you factorise it fully by having a look at your trinomial, and it may not always factorise, but if it doesn't, you'll have to prove it using your discriminant. That's, yeah, factorisation. Yeah. Now that one can be a bit annoying in that you might spend a bit of time on it, but it's just using your factors until you get that first factor, and then you've cracked it. Okay, thank you very much.